Okay, so in this video we're looking at a different form of the parabola equation, and this form of the parabola equation is called the factorised form. Now you've met this before when you factorised brackets, and you've also met this before when you've solved algebraic equations involving a parabola or involving a quadratic equation, when you've got two brackets. Now level 1, realistically the only form of algebraic solving that you could do was using those brackets. Okay, so it makes sense that we've got a form of a quadratic equation, a form of a parabola that uses those. So I've got two numbers inside my bracket, and at the moment they are both 1, which is why my graph is sitting at -1. If I change one of them, make that -5 for a second. Now my graph is going through -1 and -5. So the point that you're interested in this time is not this corner point at the bottom, which is called the vertex. We're now interested in the points where it touches the x-axis. So they are the x-intercepts, or as we call them in mathematics, roots. So if I change my value, you can see that the number where my graph is going through my x-axis can change depending on where my numbers are going through. So here I've got that one of my brackets is +1 and the other of my brackets is -5, and notice how the places where it crosses on the x-axis is at -1 and at +5, which is the opposite sign to the thing that you were having. Okay, also worth noting that my vertex is halfway between these two places, these two x-intercepts or roots. So my place halfway between -1 and 5 is at 2. So I could now work out the coordinate of that vertex by substituting x is 2 into this equation. Okay, so I can make all sorts of different parabolas just by changing where my x-intercept is, so that you can see that these numbers will all change. Now we need to talk about our last number. Our last number is this number that goes in front. It currently is a 1, but if I change that, it becomes a 2. And again, notice how my graph is stretched. Now, last time we were looking at stretch, we were looking at the completed square form, and it stretched from the vertex. This time, because we're looking at the factorised form, it's stretching from the x-intercepts, so those points stay the same, and the whole graph gets stretched or squashed from there. So again, exactly the same as we talked about on the completed square form. If I make that number bigger, it goes up quicker, so therefore my graph gets stretched more. If I make that number smaller than 1, suddenly my graph can go wider because it's getting stretched and it's getting squashed. So my graph is getting wider and wider. And then if my graph goes negative again, once again I get that upside down sad face. And again, if the numbers are smaller than 1, my graph gets squashed. And if my numbers are bigger than -1, my graph gets stretched and gets longer. Okay, again, like I said last time, I will leave the links to the GeoGebra in the YouTube page and on the site, so you can have a go at working out what's going on with these graphs. But ultimately, those are my two different types of parabolas. So I've got the completed square form, which is one where you've got one bracket and a square above it, and I've got the factorised form, which has got two brackets. Okay, so you can use both of those to describe parabolas. The next video will be talking about which one is the right one to use in different situations. Okay, so until next time.